we have previously learned the different ways that a gas molecule can move, and now we are going to relate it into energy. To do so, we need to discuss the principle of equipartition of energy. So principle of equipartition of energy says that every velocity component, either its linear velocity or its angular velocity, has on average an associated kinetic energy per molecule of half kT. So it depends on how many ways you can move. Each way that you can move has a velocity component. Just now we see that there's Vx, Vy, Vz. We see that there's omega x, omega y, and omega z, right? So this velocity component, each of them has on average an associated kinetic energy per molecule of half kT. So if your molecule have 6 different ways to move, then each different way it moves can have a kinetic energy of half kT. So if you have 6 different ways, then you have 6 times of half kT for your kinetic energy. So let's say if another molecule, they have 5 ways of moving, 5 different ways of moving. So you have 5 velocity components, right? So each velocity component will contribute to half kT of kinetic energy. So in total, you have 5 times of half kT, 5 over 2 kT of kinetic energy. That's basically the idea, okay? Nothing too complicated. Actually, the deeper level understanding is quite theoretical, but for our level, it's just simple saying that how many ways you can move, each way deserves a kinetic energy of half kT. That's the basic idea. So monoatomic gas, just now we learned that there's 3 different ways to translate, 0 ways to rotate, right? So because you have 3 different ways to translate, therefore each different way that you can translate will have a kinetic energy per molecule of half kT. So in total, you have 3 times of half kT. So for diatomic gas molecules, you have 3 ways to translate and you have 2 ways to rotate. So the 3 ways to translate will have a half kT associated with it. Then the 2 ways you can rotate will each have half kT associated with it as well. So each ways that you can move will deserve a half kT of kinetic energy per molecule. So we carry forward the discussion to polyatomic gas molecules, assuming that all molecules that we discuss here have 6 degrees of freedom. So each of these 6 degrees of freedom will have a kinetic energy per molecule of half kT. So basically, that's the idea of principle of equipartition of energy when it's applied into gaseous system.